Questions 21 through 25 of the 2001 Grade 8 AMC 8. The mean of a set of 5 different positive integers is 15. The median is 18. The maximum possible value of the largest of these 5 integers is. All right, I will let the 5 integers be A, B, C, D, and E. And they're saying that the mean is 15. So that basically means that when you add them up and divide by the total, which is 5, you're going to get a value of 15. And therefore, the sum, A plus B plus D plus E, is equal to 75, like that. Then they've told you that the median is 18. So that means that this C is 18. And I'm assuming that I've written this as smallest to largest. And that's why you're getting a value of 18 for C, because C is the middle number, and remember, median is the middle value. So now they want the maximum possible value of the largest. Now let's say that the largest is E, which would make perfect sense because we've arranged this from smallest to largest. If we want E to be the largest, we have to get the other numbers to be the smallest. So what is the smallest I can make A? Remember, they're positive integers. So the smallest positive integer is 1. How about B? Well, they are all different, so I can't make B 1, but I can make it 2. And then how about D? Well, you might be tempted to say, okay, we'll make that 3. But if you did, then C would no longer be the median. C has to be maintained as 18 and as the median. So the smallest you can make D, if C is the middle number, is 19. And therefore, this will be how you calculate for E. And if you do the math, this becomes 40 plus E is 75. And therefore, E is equal to 35. So the answer to number 21 is D. On a 20-question test, each correct answer is worth 5 points. Each unanswered question is worth 1 point, and each incorrect answer is worth 0 points. Which of the following scores is not possible? So if you get a question correct, you will get 5. If it's unanswered, you will get 1. And if it is incorrect, you will get 0. So first and foremost, what's the maximum? Well, you get all 20 questions correct. And for each, you get 5 points. And therefore, that's 100. So that is possible. What if you get only 19 correct? Well, if you get 19 correct, you get 19 times 5, which is 95. So this definitely looks possible, and 100 is possible. What about if you get 19 correct and you leave 1 unanswered? Well, you'd have 19 times 5 points, and 1 unanswered gets 1 point. And this would be 95 plus 1, which is 96. So therefore, 95 is possible, 96 is possible, but 97, 98, and 99 are not. There's no way of getting these values. So these 3 are not possible. So that would be, of the choices listed, E. Points R, S, T are the vertices of an equilateral triangle, and points X, Y, and Z are the midpoints of its sides. How many non-congruent triangles can be drawn using any of these 6 points as vertices? Non-congruent. All right. So the first one that immediately pops out is this one here, the big one. So the big one, I will draw here on the side like that. Now let's look at other possible combinations. This one right here, the small one, that would also be a possibility, but these small ones can be created in 4 different ways, right? So we've got another set of triangles, but those are all congruent to each other. So we've only got one that's unique, and I'll put that guy right down there. Okay? Even though there's 4, they're all congruent to each other, so we can't count them 4 times. We can only count it once. Now let's go back to our original grid here. See if we can figure out another possibility. How about this one here? That one. That one is unique in the sense that it is non-congruent to the possibilities that we already found. We found this one, and this one is another non-congruent one. Is there any more that are non-congruent? I think this one, this type of scenario where you've got there, there, and there, that would give you a triangle that is non-congruent to the ones that we've already found. And if you fiddle around with this, you'll find that that's it. That's the extent of it. All the other triangles will basically be congruent to either this one, or this one. So in terms of non-congruent or different triangles, we've only got 4 choices. 1, 2, 3, and 4. So that means 23. The answer is D. Each half of this figure is composed of 3 red triangles, 5 blue triangles, and 8 white triangles. When the upper half is folded down over the center line, 2 pairs of red triangles coincide, as do 3 pairs of blue triangles. There are 2 red-white pairs. How many white pairs coincide? Okay, let's work with this here. So we've got this center line that's very important right here, because you're going to flap basically it over so that it becomes on top of each other. And then the total in terms of the triangles is 3 red, 5 blue, and 8 white on each side of that black line. All right, let's start filling this in. When you fill it in, 2 pairs of red coincide. So anywhere, it doesn't matter as long as you make them coincide. So that's 1 pair that's going to coincide when you join them. You flip one side over the other. And the other red one you can put anywhere you want. So I'll just put it here. And that satisfies the first condition. The next condition is that 3 pairs of blue triangles will coincide. All right. So the blues I'll put here. And then that means they have to go here on the other side, right? Because when they're folded, they will coincide with each other. And then finally, 2 red-white pairs coincide. So if that's red, then that has to be white. And if this is white, that has to be red. Because I can't put the reds on both sides, because on each side you only have 3 reds. So all the 3 reds I've used up, and I've used up 3 of the B's, right? Because there's a total of 5 B's. So I'm going to put 2 more B's on both sides. Let's just put them there. And then on the other side, I cannot put them there. Why? Because that would not meet the conditions of the question, because only 3 pairs of blue triangles coincide. So the blue have to go somewhere else. So I'll put the blues here, like that. All right, I've used up all my blues. Now the only thing left are the white. So far I only put 1 white on both sides, so I've got to put 7 more. 1, 2, 3, 4, 5, 6, 7, and that matches up perfectly. All our triangles are now filled. Now what do they want us to figure out in the question is how many white pairs coincide. So how many are white, like this, when you match them? Okay, well, let's look at this. How about this one here? Does this match? It matches with this one, so that's 1. This one is another match. This one is another match, and as this one and this one. Are there any more? These 2 white ones at the top here do not match. They actually will match with the blue, and then all the ones that are white here This one is white, red. That one is blue, white. This one is blue, white, white, red. Okay, so there's only 5 white, white pairs. So the answer for number 24 is B. There are 24 4-digit whole numbers that use each of the 4 digits 2, 4, 5, and 7 exactly once. Only one of these 4-digit numbers is a multiple of another one. Which of the following is it? So we can very quickly figure out that if there's 24, you've got 6, 6, 6, and 6 in terms of the groupings. And the first 6 all begin with 2. All right? And you can very quickly write them out. 2, 4, 5, 7, 2, 4, 7, 5. 2, 5, 4, 7, 2, 5, 7, 4. 2, 7, 4, 5, and 2, 7, 5, 4. All right? You can very quickly write them all out, and then we can look at them a little bit more carefully. Similarly, 4, 2, 5, 7, 4, 2, 7, 5. 4, 5, 2, 7, 4, 5, 7, 2. 4, 7, 2, 5, and 4, 7, 5, 2. Right? So we got 5, 2, 4, 7, 5, 2, 7, 4. 5, 4, 2, 7, 5, 4, 7, 2. 5, 7, 4, 2, 5, 7, 2, 4. And finally, 7, 2, 4, 5, 7, 2, 5, 4. 7, 5, 4, 2, 7, 5, 2, 4. And finally, 7, 4, 5, 2, and 7, 4, 2, 5. All right, great. So they're saying in these 24, one of them is a multiple of another one. So there's no magic here or trick. You just kind of look through these and say, okay, we'll start with this one, 2, 4, 5, 7. If I multiply this by 2, will it show up anywhere in here? And the answer is no. If you'll multiply by 3, will it show up anywhere? And if you do that very quickly with 2, 4, 7, 5 actually, you will realize that if you multiply 2, 4, 7, 5 by 3, like this, it becomes 7, 4, 2, 5. And 7, 4, 2, 5 is right here. It's the last one. And that's what they're asking for. One of these 4-digit numbers is a multiple of another one. And which one is it? It's 7, 4, 2, 5. So that would be answer D.